Hello, everyone. So after I posted this video for translating IES VE models to eQuest, a couple of people reached out and asked if they can do the same from an OpenStudio or IDF file, EnergyPlus model. The answer is yes, you can totally do that. And I'm recording this video to show you how to do that. It's very similar. Again, you bring the model in, validate it, and then export it, but I'm going both to show how to export to eQuest and how to export to IES VE. So we start with an OpenStudio model and go to these two different platforms. And I'm going to show some specific fix for each platform. Um, the model that I'm using is this model from Unmet Hours. It's modeled by Mafalda Korea around 2 years ago. So thank you for sharing the model. And at the time, she actually shared the model for daylight simulation. So you can bring it to Rhino and then use Pollination running daylight simulation. So this is how daylight factor looks like in that building. But you can also use it to export it to other platforms, as I'm going to show you to you today. So let's go ahead and import the model to Rhino. You just press Control O or open, and you open the OSM file. Because it is, I have Pollination Rhino plugin installed. Rhino natively can open OSM file. It's the same workflow with EnergyPlus IDF files. I'm going to select no for validation initially, let it import, and then I run the validation command. So let me go here. The reason I selected this model is one, of course, it's a real world model, so it has issues that we can solve, so we can get a taste of what can go wrong. The other one is these two skylights here, and if I go to top view, this is not modeled the way we usually model energy models. It's just you try to keep it orthogonal and then change the north orientation. That's easier. But in this case, she decided just to really model it on the where the north and south is. So just rotate the model itself and keep the north in y plus direction. This will become an issue when we export it to eQuest. I want to show it to you so you know that's a limitation that we have, and the fix is just to rotate the building, of course. So I'm going to do that too. And yeah, but there will be no issues to export it as is to IES VE. Okay, let's get it started. So first step, let's check and make sure the model is valid. So I'm going to use the PO validate model command and run it for the whole model. There are two categories of errors. One is invalid subface. This is under all doors. So this is very common. I select all of them holding down shift. And the doors that are modeled and they're touching edge of the room will be considered invalid. In Pollination, the fix is very easy. You just do PO offset child objects, and then I'm going to offset them for 5 millimeters. I'm going to select this room and the other room on top. I'm holding down shift and click. Um, so that should be done. What I'm going to do, I'm going to click on revalidate again, press here, and command line press enter, and that's done. So that one is resolved. The other issue is found missing adjacency. So there are three faces that the adjacent faces are not available. This is most likely happening because there was a tolerance issue in the OpenStudio model, and then Rhino plugin tried to fix it. So for example, here, you see that this face, the bottom face, is a single face. However, you have separate rooms here, so this should have been broken into smaller pieces. So one thing I'm not going to do, so if I, actually, let me close this and go here. So this, in this particular model, let me uh, make it color by boundary condition. So I'm going to select all the shades using command PO underline cell shades. and press Control H to hide them to show you this. So in this particular model, these areas are actually set to adiabatic. So the blue is the ones that are outdoors. This is adiabatic, and this is ground down here. Um, so let's fix this. So I'm going to fix this one on top by running PO solve adjacency between those PO solve adjacency. I'm selecting this. There's 4 rooms here. Intersect, yes. Face match, yes. Construction override, everything else set to no. And now when I run this, and I'll go back and color it, you'll see that it keeps the boundary condition for these ones that they were adiabatic. So it doesn't overwrite those. But at the same time, now if I select this, you'll see, sorry, select the roof, you'll see that this one is a splitted, so this is now correct. I'm going to do the same here for this room that was problematic, so solve adjacency, select, and solve. And now if I run PO validate model, the model should be valid. Okay. So what's important here and why I did this one, because when we export to eQuest, we do more than just geometry. The boundary condition is there. So all these faces will be exported as adiabatic. I'm going to use the command show to show the rest of the geometry. I'm going to click on this button here to color by face type because it looks better. And I'm going to save it at this point. So save. Okay, so import the model and validate it. Next step, let's export it to eQuest. Okay, now that I have a valid model, I'm going to export it to eQuest. So the way you should know, save as IMP as the file type. If it's not selected, you go to find eQuest and save it. It takes a couple of seconds. You see, I already did it. Then I realized I don't have eQuest open. So I'm re-recording this. So eQuest is open already. So I go open, go to this folder, change this to INP, the file type, and then select it and press OK. It will show up on the other screens. Let's see if I can grab it and bring it here. Here we go. I got it. So it goes here. No errors or warnings. Everything is imported. Shades. And you can see levels based on the floor levels and the staircase because it's basically modeled as a single space all the way. It comes all together here as part of the level 0. I mean, you can break it down if you want the staircase to see it in every level. So the part that I was saying as a limitation is this part. So if you check, you'll see the skylight here is rotated. The reason for that is the way we export um, models to eQuest is we use the absolute value of like where the polygon is as XY, and then eQuest defines the window by getting an origin, like basically a distance from the origin of the parent face, and then XY for the size. And because there is no way to rotate this aperture inside the parent surface, and because for the parent surface we didn't model it as like a face that then you rotate, so that's where the problem comes. I mean, this is something that technically we can go back and fix it, but it can introduce new issues. So the easy way is just when you model, uh, just model it. I'm sorry. So rotate, object rotate, and then I'm sorry, I did rotate 3D, I think. So let me go back. Rotate, select, click here. This is my reference. Hold down Shift, and then rotate. And now this is in the XY direction, right? And now if I do save as, um, And this time I call it rotated, rotate. And now go back to eQuest and do all the import process again from here, INP rotated. Save. Okay. You'll see that problem will be gone. And I believe there is a way similar to other simulation software to set the north uh, orientation by degree, north axis by degree. So let me go to 3D geometry, and here you go. So everything is fixed. So this was the eQuest import export. Oh, and I didn't talk about, so you can see here, these are set to adiabatic. And if I go and turn off shades, um, building shades, close. I failed. What are these ones? If I go here, and do we have different window shades? What are the other shades I can turn off? If I could have, uh, that's interesting. If I could have fixed shades. Okay, that's what they are, I think. Okay, now you can see these are set to adiabatic, the ones that were adiabatic in the model. Okay, I think with that, we have the doors, we have the apertures, we have the geometry, we have the skylight. This is your export model to eQuest. Next one, let's go and do export the model to IES VE. Okay, so for export to IES VE, I mean, I can just save it as is because it's a valid model. There will be no issues, but let me do that and then we start doing some optimization. So if you're in a rush, you can just do this. Sorry, ISVE gem save a couple of seconds, and then you can just import BIM file gem. Oh, actually, let me go back here before I export. So go top. No, I'm going to just do the one before rotating it. So I'll just go back to what it was. So you can see that's actually fine with ISVE. I'm going back here. I'm going to run the save as again. And let's overwrite this file. Yeah, that was only something for eQuest. So in IES VE, I can do this. And then gem file open, and you see it's all good. Or is it? So we get it here. So the model comes in, the geometry is fine, everything. But there are two things here if you want um, to basically, I don't know how you refresh it. I think you have to rerun this. If you want to optimize, one is, so this model has, it's hard to see these lines with this color, but because the faces are splitted here, you see with the adjacent shade, you get these lines here. Maybe it's useful actually in this model because if you want to set these ones to adiabatic, similar, so this is good. But if you want, you can rebuild the model in Rhino so you don't get these lines. So this one I'm not going to bother to change, and it's quick fix. But the one that I'm going to change is, you see like all the shading faces came as like one per unit, basically, and that's way too many of them. And that's because in Rhino, they're basically now like everyone is a single face when the shades are created. So to optimize that, oh, that's one. The other one is everything came in as, and I always forget, local shade. There is no neighbor building, but I imagine you want these ones to be neighbor building, right? These are no local shades, and the same with all these buildings here. So these ones in the center are local shades. So what I'm going to do, I'm going to use the command PO cell rooms to select all the rooms and then press Control H to hide all of them. Then I'm going to select this shades that I think they should be local shades and hide them too. I mean, of course, you can use layers. Like that's the better way probably to put them in different layers and turn them on and off instead of using show and hide. But yeah, this is also a way to do that. So what I'm going to do, what I want to do, so I pressed on this turned off color by face type. I'm going to change the mm, change it from wireframe to be ghosted so we can see the geometry. What I'm going to do, I'm going to make these shades as solid or closed B-wraps as they called in Rhino and or closed poly surfaces. Closed BRF is what's called in Grasshopper as closed poly surfaces. And then when I do that and export them as shades, they should come as single shades each. The other thing is I'm going to change these to be outdoors, like so building context, what we call it. And in IES, I believe it's called neighbor buildings. So to do that, so this is so I think this one is one building, I would just say. Let's do this as second one. And all of this, I'm going to join them into a single one. So I can show you some Rhino stuff too. So the first thing is these are now shade geometry. I want them to be the default Rhino geometry. So I'm going to use the remove PO underline remove properties command to remove all the properties. So now if I go here, click, you see they're like the ones that we have as shades are actually hidden. So none of these are now shades, they're just surfaces. Um, Now, what I'm going to do, this one is easy. I'll just select everything and type join. You can also press Control J, and now you can see this is one closed poly surface. So this is good. Let's hide this too for now, or should I? Yes, let's hide this so I can show you how to do this stuff. So for this ones, we have some shared faces here. So selection might not be the easiest for someone who don't know how to work with Rhino, but just watch a few videos. Oh, and what is this one here? There is a small geometry here in the between the two. That's not good. This thing here, right? So this looks like an error to me, like a mistake. But for now, let's keep it like we cleaned that up. Then what I'm really going to do, I'm going to select these guys here, right? And I'm going to hold down Shift and select this. Oh, that's the wrong surface. That's the wrong surface. Hold down Shift and select not this surface, this one. And there should be another one here. I select all of this. And then let me see, is there a surface in middle too? So if I press Control J, you'll see that there is one here and there is one here. So this is one is open, this one is closed poly surface. So this one is closed. I'm going to hide it. We're good with this. Why is this one open? So the way to know that is, I mean, you can run the command cap to quickly cap it, but it says I can't cap it because there's a non-plane or something. So there's a command called show edges that shows the naked edges. And those are the naked edges. So now the question is why I couldn't cap this? Because probably I selected this guy here, the small one. Yes, so I'm going to explode this. I think that's the place that I should stop doing all this fixing and stuff because people stop watching now. Because like, oh my God, too much Rhino 3D here. And I think you're right, but this is happening because this was not modeled clean in the first place. So I can do Control J for this one and then cap. So this one is done. For this one, as I said, I consider this a mistake, a modeling mistake. Um, what I'm going to do, I'm going to delete this small face and actually delete this and delete this one too. And I'm going to, for the rest of it, so let me actually make things cleaner. So I'm going to move this back, this time next to this wall. I'm going to hide it. And now that gives me time to clean this up. And honestly, this color is one of the worst colors for working. So let's select a better color so we can see the edges of this. Okay, so now for this, I can have a few different approaches. As I said, I want to model all of this together. So what I'm going to do, I'm going to uh, basically remove all the things from the middle. I don't know how this is modeled. Yeah, there are smaller faces here. So I'm going to select all this smaller faces in the middle of the geometries, and I'm going to delete them so I can make one single geometry. Okay. So one thing that we will see there will be a problem is this small difference here. So what I'm going to do, I'm going to move this back. And we can model it as this, you can patch that, but like for a shade, you want it to be cleaner. So I'm going to trim this thing here, here, and here. And now if I select everything and do Control J, let's see what we got. One closed poly surface. Then next I'm going to run a command rebuild. No, it's actually called merge all coplanar faces. So it cleans up everything. So I don't have that many additional faces, right? So now if I do show, you'll see that I have this shade objects that are now built as closed B-wraps. Why it's important because now if I go here and start creating them as shades, so I select add shade here, and I'm going to select side context shades, and then select them. I'm going to select this, this, and that. And now they are converted to side context. And if I call them, you see the color between these two are slightly different. So these are the shades that are building shades, and these are not the ones that are um, shades for neighbor building. So now, one thing that I didn't show, and if someone wants to say, okay, I didn't want to remodel them, I just wanted to show them to be from local to not to be local. You don't need to do all those. So what you can do, you can just select those shade faces and do PO edit shade properties. And here in shade properties there is one is side context. So if you set this to true, if you select it, that means it's a neighbor adjacent building. If you don't, it's a local shade in IES language. So for this one, I'm not going to select it, but now you know how to do that. Okay, now let's save the model here. If I do save as, so we call this 2, and I go back to IES and File, new project. Now if I go to File, Import, Beam file, gem file. Now you'll see that it came in. These are neighbor, and this is local. Okay, and let's see if this is now correct. Yes, you see every single of them are modeled. So these are the local shades, and these ones are also grouped together. So you don't want to have that many shades separate shade objects in your IES model. I know I spent a little bit, probably more than I should have, on cleaning up, but I hope you learned something new and you just learned some cleaning up routines. If you want, as I showed originally, like before cleaning up, you can just export them. It will work. You'll get what you want. It's up to you. Thank you so much, and let us know what you think. If you have any questions or you need some new interoperability workflow, let me know. Um, um, we'll be happy to record more videos like this. Thanks a lot.